Hi guys, good to see you after a long spell. Haven't done anything major, or not videoing. I've done a handful of very small bits and pieces, not worth recording. And in fact, this last weekend I had to weld up 2 broken pieces on a lawn tractor. That would have been almost impossible to video, apart from which it was an absolute killer job. Difficult access, absolutely ruined my back, but I had to do it. It was too hot too, so sweat everywhere. Anyway, this is just a short intro. Somebody suggested quite a long time ago, they said, oh, why don't you rerun one of your old videos? And I thought, well, as a lazy option, why not? And what I thought I would do is go back to one of the things I made quite a long time ago, low profile clamps, which have proved very useful. And what I'll do is run all the clips together with a lot of speeded up sections and some subtitles, and get through it a lot quicker than the original took, just to give an idea of the basic project, because it was one I was quite pleased with, and it might be worth resurrecting that. So if you've seen it before, don't bother. If you haven't seen it, hopefully you'll enjoy it, even though it's going to be rather compressed, but give you an idea of how I went about it. Alright, that's it for now. Thanks for watching in advance, and I'll be back sometime, hopefully. Take care of yourselves, particularly you guys out west in the mid-plains. Yes, weather again. I always talk about weather, but you have had an absolute hammering, and I really feel for you. At the moment it's towards the end of May, and it's been a vicious month in many ways. Anyway, take care. Bye for now. The starting point here was an old gate valve threaded section. The idea being to turn off the thread and get down to something approximating 1 inch in diameter, and a good way to get some useful brass. We got most of the thread off, and it's mainly a case of taking it down to a near finished diameter. It's a pretty slow cut on this one. Not a bad finish, but still one final cut to come, just to finish off. Last pass. This is using an HSS tool bit, and then we'll take it to the bandsaw and cut off the flange and just finish up with the main piece. So we've got to face off this piece, but initially here's a look at the bolt I'm going to use. It's actually 8mm metric. There are several reasons for choosing that. One is it's what suits the purpose and the head size is suitable for what I plan. We're going to turn that down later. Now just face this off to get a decent end before we drill down the middle. Now drilling down through, we've got to actually go 3 inches, probably a little bit more, to allow for parting off and losing material. A bit tricky having to use the whole length of the drill to do the job, but it does get there in the end. We're going to part off to get 6 of these buttons, we'll call them. We're pushing the limit on the drill bit. Now parting off the first button, using a file just to get a little bit of chamfer before we finish parting. The file is always very useful. and then finish parting off using the tailstock centre pillar because we've got rather a lot of stick out. Now the button thickness comes out at 475, and that leaves about 80 thou underneath the cap screw head. And then on to number 6, the last button. Just a straightforward parting off process. That more or less finishes off the lathe work on the brass. So there we are, 6 buttons. I'm going to polish those on some 600 grit just to clean up the machining marks from the parting operation. Now, spare piece of aluminum here, just putting a thread on it, M8 thread, so that we can put the cap screw into that and then set the whole thing up in forge yaw later for eccentric turning. Checking for fit, although it looks as though I haven't cleaned the threads very well on that bolt screw. Just take it out. It has freed off a bit actually. Now the other thing we want to do, because we're going to be turning the diameter of the cap screw head, is we want a little bit of relief behind that, because then it gives us space for tooling. Now we're going to want a good fit with the cap screw head in the button. We're going to turn that down. You see the spare space for tooling there. We're going to turn that down to just under 7/16 so we can use that size of end mill for our counterbore. So we've got the 6 buttons. We want to put them all together into a group so we can machine flats on opposite sides just using a piece of all thread. There's a little bit of slack, not much, but it's not very critical actually, not super critical. But before tightening up, we'll put the whole group on the piece of aluminum there to get fairly straight, and then tighten it up. So that's got it reasonably cinched up, and then follow that with a check visually with a straight edge, see if things look okay. Now to the mill. This is the first side we've machined, taken several passes, and taken the main material off, and now inverted it and taking a cut on the second side. This is probably close to the last pass, using a small fly cutter which is doing quite an adequate job. And then we can dismantle the whole thing and clean up, deburr obviously, and then we've got 6 buttons ready for use. Back to the lathe with a cap screw in the aluminum arbor, and turning that down. Of course we want to get a smooth surface as well as down to diameter. Like I said, we're heading for 7/16 minus a thou or two. We set up eccentric, of course, in the forge yaw. Let's check the final diameter. We want it to be a good fit in the button. Now that mirror hopefully just about shows the offset we've achieved. You'll see it a bit clearer later. So, all 6 prepared and ready to go. Using an old 3-jaw chuck in the mill to do our counter bore, 7/16 end mill, and then check for fit. And that looks pretty good. Very little slop, but free to move. Another look, and this is actually the clearest probably of seeing the offset we've got, which is about 30 thou, which is hopefully enough for the camming operation. Next we've got to do something about T-nuts, so we've got a piece of mild bar, and that should suffice for what we want to do, and we'll machine that full length. Just using indicators here to tram in the workpiece prior to milling. Now machining up the first side of the bar. Looks like I'm going to lose the oil can. So straight up, obviously speed it up a lot. Using a roughing end mill. No great importance for finish on this job. Down the second side to get to finished dimension. Quite adequate really. And we're sitting on a couple of parallels there to get the necessary height. Just a closer look at the bar, which we now need to chop up into pieces on the bandsaw. Well, for some reason I couldn't find all the clips on my hard drive that I wanted to finish, so I've had to use the original part 4 that was on YouTube, take out the clips I need, and hopefully it'll work out alright. Onto the bandsaw, chopping up the chunks, pretty straightforward. While the 4-jaw was in the lathe, decided to use the lathe to face off these pieces, just to clean them up from bandsaw cut. Quite adequate. So we've got all the pieces, and these then need marking up, ready for drilling and tapping. In fact, the amount of space available, I should have made these slightly longer, but with a bit of juggling we can work it out. The button is a little bit close to the end, but we're okay. And the set screw is actually an SAE size, all I could get for the right length. This set screw cup end, going to grind that off and get a decent flat, which is going to be kinder to the T-slot base in the table, and give a bigger surface area as well for tightening up. Pretty much free-handing this operation, having got decent center pops. Just using a center drill to get a good starter for the tapping drill. 2 different sizes of tapping drill needed, of course, because of my selection of threads. Doing some thread starting in the mill. Probably get a couple of turns or so, and then finish off by hand. Finally, all the components ready to use. Bit of a pain doing different threads in these T-nuts, but we got away with it. So now we can get round to setting this up on the mill table and see if it works. Well, here we've got a regular shaped piece of aluminum bar locked up and pretty tight. Should be tight enough for machining. Now, setting up's fairly straightforward. Each button wants to be positioned so that the thin wall of the camming bolt is facing inwards, and having slid the T-nuts into contact with the workpiece, both sides, and then do up the opposite side. This is all depending on how you want your workpiece aligned. And then turning the camming head on each side evenly until you've got a good tight grip. That basically is it. Now let's undo the whole workpiece. Not in any particular order. Turn the cam bolts sufficient to loosen the grip of the buttons equally, both sides. And that's it, the piece will come out, which can be incidentally an irregular shaped piece. I should point that out. Now, tightening up again, equal, both sides. Takes a little while, which can't be avoided, but the benefit is the low profile clamp size. There we are, that's about it. Now we're fixed again, ready to machine.